Alright, we are on our last section from Chapter 8 that we're going to cover, and then we're going to do one section out of Chapter 9 next week, and that will be it, I believe, is my plan currently. So this section is going to be kind of a continuation of what we were doing the other day with like we were multiplying and dividing rational expressions, now we're adding and subtracting them. Get my thoughts straight here. So we're going to be looking at 8.5, add and subtract rational expressions. Paper down some. Alright, so the first thing we need to look at is adding or subtracting with like denominators. Okay, like denominators being the key for this one. We'll also do it with unlike denominators. And to add or subtract rational expressions with like denominators, simply add or subtract their numerators. Then place the result over the common denominator. So the two properties we're going to have are, we need to say that let A, B, and C be expressions. So they're not just numbers, they're expressions, with C not equal to 0. So the property for adding says that A over C plus B over C is equal to A plus B over C. And for subtracting says that A over C minus B over C is equal to A minus B over C. Alright, so that's that property. And then, like I said, we do have this property as well for unlike denominators. So that was for like denominators. Now let's look at unlike. So adding or subtracting with unlike denominators. So to add or subtract two rational expressions with unlike denominators, find a common denominator. And I'll show you how to do that with these expressions in a minute. Rewrite each rational expression using the common denominator then add or subtract. So we would say for this one, to get the property, let A, B, C, and D be expressions with C not equal to 0 and D not equal to 0. So then the properties for addition is A over C plus B over D is equal to, so we need to get the common denominator, so it's AD over CD plus BC over CD is equal to AD plus BC over CD. And then for subtraction, A over C minus B over D is equal to AD over CD minus BC over CD. So AD minus BC over CD is ultimately what we get. And I know that's probably confusing just seeing a bunch of letters because these aren't even expressions, and you're probably like, I already know how to do this. Why are you teaching this? But we're going to get ready to do these where these are actually expressions. Okay, in just a second I'm going to show an example. But the other comment that the book makes here with this is that you can always find a common denominator of two rational expressions by multiplying their denominators as shown above. However, if you use the least common denominator, which is the least common multiple of the denominators, you may have less simplifying to do. So it might be easier to find the least common multiple, but this multiplying this one by this denominator and this one by this denominator is always an option, and that's the method I will probably most commonly use, though not always. Let's see. I'm going to try to keep us away from ones that have, or from the complex fraction stuff. I'm not overly worried about us really doing those right now, so we're just going to stick kind of with these rational expressions, just kind of hitting the main stuff out of this section. So, let's go ahead and jump into some examples. Alright, so stuff like 3 through 8 is with a like denominator. So I'm just going to do one of these because this should be pretty simple. Well, okay, I'll do two of them. 6, just because of the way that they write them. 3x squared plus 6x, well, both of these, sorry, are over x minus 8. So, since I basically gave you the answer, okay, we write the top two things together over one of the bottom denominator, so we get 3x squared plus 6x over x minus 8. Okay, but we want to factor stuff out if we can to simplify it down as much as possible, just on the off chance we can cancel stuff out. So we would factor out a 3x, leaving us with x plus 2 over x minus 8. And that would just be your answer for that one. And then let's do one more of this, number 8, just because this one's written a little different. 4x squared over 2x minus 1 minus 1 over 2x minus 1. So I combine the top, so this is 4x squared minus 1 over 2x minus 1. But we can factor the top. Okay, it ends up being a difference of squares, so it's going to be 2x plus 1, 2x minus 1. So 2x plus 1, 2x minus 1, all over 2x minus 1. And then because of us factoring this, it enables us to cancel these two things out and leave us with 2x plus 1. So just always make sure you factor it out and simplify it down as far as possible. Because we would not want to leave it this way. We would want to take it all the way down there. So then now let's do some unlike denominator ones. So we'll spend some more time with these ones. So unlike denominators now. So we're just going to stick with the ones that have 2 pieces. Okay, so like this, we're not going to go into the ones that have 3. That's a later part, and I'm really just worried about these 2 because really and truly, if you can do 2, you can do 3, 4, 5, however many I give you. But I'm not going to give you ones like that at this point. So let's start with an easy one here. 16 is 12 over 5x plus 7 over 6x. Okay? And it's going to take a little while to get used to this stuff. So if it's taking you a little longer to get this stuff, don't stress about it too much. That's kind of why I just did 2 sections this week. I wanted to give you guys some time to kind of process this stuff. So on this problem, we have 2 options. Okay, we have 5x on the bottom and we have a 6x on the bottom. So what the one method is saying is that I could just take and I can multiply the top by 6x here. I can multiply 12 by 6x, and I can multiply 7 by 5x. And then on the bottom over here, I'd have 30x squared. However, an alternative option, okay, is to multiply this by 6 over 6 and this by 5 over 5. Okay, obviously we're multiplying top and bottom. It just didn't look like it before. And if I do that, it gives me a common denominator of 30x. And I'm getting ready to write this out. But it gives me the common denominator, and it will require less simplifying later. So I'm going to, just so you can see the steps, 12 over 5x times 6 over 6 plus 7 over 6x times 5 over 5. So this gives me 12 times 6 is... Goodness, I'm blanking on that right now. 72? We're going to hope that's right. 72 over 30x plus 7 times 5 is 35 over 30x. So then this ends up being 107 over 30x. And I don't think I can pull anything out of that, so then I would just leave this as my answer here. All right, so next one. Let's go with 20. Three over x plus 4 minus 1 over x plus 6. So again, with this one, it's not real clear. Something I can just multiply like one thing by like I did in this one. So I'm going to multiply this fraction here by x plus 4 over x plus 4. I'm going to multiply this fraction here by x plus 6 over x plus 6. So you can see it here, 3 over x plus 4, x plus 6 over x plus 6, minus 1 over x plus 6 times x plus 4 over x plus 4. So now on top here, I'm going to end up with 3x plus 18 over, and I'm going to leave these in factored form. I'm not going to put them back together. Minus, now x plus 4, okay, and I'm leaving this minus sign out front. I didn't put it through yet, okay, and then x plus 4, x plus 6. Now, because this is subtracting, the subtraction sign's got to go to both things here on top. So this gives me 3x minus x is 2x. 18 minus 4 is 14 over x plus 4 times x plus 6. And the only thing we can do on the top is to pull the 2 out here. So this is 2 times x plus 7 over x plus 4, x plus 6. And that is all for that problem. Let's see, 22 looks like a good one, so let's go with that one. Alright, 22, x plus 4 over x squared minus 4 minus 15 over x minus 2. Okay, so this is one where it would greatly benefit from, because this is a difference of squares here, we need to go ahead and factor this out, and it'll make our life a lot easier. So, x plus 4 over x plus 2, x minus 2, minus 15 over x minus 2. Okay, so now notice here with this one, it already has an x minus 2, as does this one. But this one here is missing this x plus 2. So all I need to do is multiply this by x plus 2 over x plus 2. And then I have taken care of all I need to do for that problem other than just, you know, multiplying stuff through. So this is x plus 4 minus 15x minus 30 over, okay, because I went ahead and just did the negative 15 through on that one. I didn't leave it out separate, okay? So then over x plus 2, x minus 2. So now here, combining stuff on the top, I have negative 14x minus 26 over x plus 2, x minus 2. So then here on top, I can pull out a negative 2. So negative 2, and that leaves me with 7x plus 13 over x plus 2, x minus 2. And that should be all for that one. I'm going to go ahead and do one more just to make sure we've covered our bases with everything. So we're going to do number 24, and then that will be it. Alright, so 24, we have x squared minus 5 over x squared plus 5x minus 14 minus x plus 3 over x plus 7. Okay, oh, sorry, too much. So we need to factor this bottom piece here if possible, so I'm going to attempt to do that now. So x squared minus 5 over, so let's see, we have 14, so that could be 7 and 2, so plus 7 minus 2. X plus 7, x minus 2, minus x plus 3 over x plus 7. And then we're set up the same way as we were with the last one. So with this one, okay, I already have the x plus 7 here. The only thing I'm missing in this one is this x minus 2. So I'm going to go ahead and multiply by x minus 2, over x minus 2. So then I end up with x squared minus 5. Now I'm going to go ahead and leave this subtracted here because I need to go ahead and factor this stuff on top. So this is going to be x squared. Here, hold on. X plus 7, x minus 2. So I can actually keep this stuff straight. So this is x squared plus 3x minus 2x is plus x. And then 3 times negative 2 is negative 6 over x plus 7, x minus 2. So now I have a common denominator, so I need to take this, and I'm going to do this just so I remember that I'm subtracting here. Sorry guys, I keep pushing the paper up and not realizing what I'm doing. Alright, so I have on top x squared minus x squared, so those x squareds go away. And then I have minus x, and then negative 5 minus negative 6, so that's negative 5 plus 6 is plus 1 over x plus 7, x minus 2. And that is it, and we are done with that problem. Alright, so I know these are kind of just different. Like I said, sometimes it just takes a little bit more time, but if you guys have a question, just let me know. Since we're just doing one more section, you'll have one more section, a few review problems to do next week, and then a quiz on either Thursday or Friday. I can't remember what I had said or if I had said that already or not. So we're going to do that, and then we will be done for the year. So about a week left, guys. You can do it. Oh, I guess you guys want homework, though. So that would be helpful. Thought you were going to get off easy there. 3, 5, 7, 17 through 25, odd. Alright, and then that is it. There we go. See, I was going to give you homework. Just had to psych you out there for a minute.